Now we're going to evaluate logarithms and find out what the change of base theorem is. Special logs, this is at least the third time you've seen this. Common log, you'll see it this way, but it's understood to be base 10. Natural log, you'll see it like this, but it's understood to be base e. Now the two log keys on your calculator, here's your log and your ln, reflect these particular logarithms, and these keys are used to find the exponent that's needed to raise that whatever the base is in order to get your number. So in this one right here, the log of 100, well, I could rewrite 100 as 10 squared, and if you remember, whenever this little base here is the same as that, it should equal my exponent. So let's try it on the calculator. Log 100, enter. There's my 2. Now this one I can't write as easy as I did the other one. So I'm just going to type it in. So log 57. And remember, I'm asking the calculator, what exponent do I need? Remember, logarithms and exponents are the same thing. So to fourth decimal place, 1.7559. Well, let's see something. If I raise 10 up to 1.7559, remember, I rounded up. I should get very close to 57, but over it. Okay? This one wants us to find the exponent needed to raise e to get 92. So ln 92, enter. So it should be 4.5218. Let's take natural log of 2 ninths. Natural log 2 divided by 9. Negative 1.5041. How about natural log of 17? So natural log 17, 2.8332. Log of negative. Now I put this in not as a trick, but guys, remember, when you take the log of something, remember the number after it must be greater than 0. So this does not exist. There's no real answer. Let's see what your calculator will do. Non-real answer. Okay? And when you hit go to, it's blinking. Nope, can't have that. Alright. Now, these keys here are only when we have base 10 and base e. Well, what if we have a different base? Well, this is what's called change of base. These log keys can also aid us in evaluating logarithms that are bases other than 10 and e. So, notice log of my number goes numerator, log of base goes bottom. Or I could do ln of this number over ln of b. Sometimes I like an n here, so that'd be log of number goes numerator and log of base goes bottom. The only thing with this change of base is you have to be consistent. If you like log, then you got to use log top and bottom. Same thing with ln. Now let's look at these. 32, before we go do this, 32 can be rewritten as 2 to the 5th. So if my base here equals that base, then whatever my exponent is my answer. So this should be 5. Well, let's go see if this works. I think I'll use log first. Log of number goes numerator, divide by log of base goes bottom. There it is. This one, now 81 can be rewritten also. That would be 3 to the 4th. So this answer right here should be 4. Well, this time I'm going to try ln of 81 divide by ln of 3. And there's 4. So if you go 3 to the 4th, that will give you 81. So go try this one, whichever log key you want to use. And if we have to round to the fourth decimal place, then it would be 4.0875. So 2 raised to the 4.0875. I rounded up, so it should be a tad over 17. That's a tad over 17. Okay, try 10, 11, and 12. Maybe pause me and then get me going again. We'll see if we agree. 1.9066. Natural log 81. Number goes numerator, divide by ln of base. -4. Last one. 2.4333. And that's all for this one. Thank you.